Owls are among nature's most mysterious and captivating creatures, renowned for their silent flight, haunting calls, and piercing gaze. But behind those mesmerizing eyes lies a unique visual system unlike any other animal. Most people assume that owls, like humans, can move their eyes to glance around. In truth, owls can't move their eyeballs at all. In fact, they don't even have eyeballs, at least not in the way we understand them. Instead of spherical eyeballs, owl eyes are shaped more like elongated tubes. These tubes are held firmly in place by bony structures called sclerotic rings. These rings provide rigid support, making it impossible for the eyes to rotate within the sockets. Humans, on the other hand, have round eye sockets that allow their eyes to roll and shift, giving us the ability to look left, right, up, or down without moving our heads. Owls lack this flexibility, and as a result, their gaze is always fixed straight ahead. To compensate for their immobile eyes, owls have developed remarkable neck flexibility. When an owl wants to survey its surroundings, it doesn't glance sideways. It twists and turns its entire head. An owl's neck contains twice as many vertebrae as a human's, allowing it to rotate its head an astounding 270 degrees in either direction. This means an owl can look nearly all the way around without moving its shoulders or body, a skill that is both impressive and mysterious to observe. Additionally, they can tilt their heads up and down by about 90 degrees, granting them an even wider field of view. This head movement is often accompanied by a distinctive bobbing and weaving motion as the owl seeks the best vantage point to scan for prey or threats. Not only are owl eyes immobile, but they are also enormous in proportion to their bodies. An owl's eyes can account for up to 3% of its total body weight, a staggering statistic when compared to the human ratio, where our eyes make up a mere 0.003% of our body weight. These oversized eyes provide several advantages. Their sheer size allows more light to enter, which is crucial for nocturnal hunting. However, there is a drawback. Owl eyes are highly specialized for distant vision, making them extremely far-sighted. Objects that are close to the owl appear blurry and indistinct. To overcome this limitation, owls rely on sensitive whisker-like bristles located around their beaks. These bristles act much like a cat's whiskers, helping the owl sense nearby objects and navigate successfully even when its vision fails at close range. Owl vision is also distinguished by exceptional binocular capabilities, a feature shared by all birds of prey. Binocular vision refers to the ability to focus both eyes on a single object, resulting in superior depth perception. In the animal kingdom, eye placement is a significant factor in determining a creature's field of view and depth perception. Animals with eyes on the sides of their heads, like sparrows, enjoy a wide field of view, sometimes as much as 300 degrees, but only a small portion of that is binocular, sometimes as little as 10%. In contrast, owls have eyes set at the front, giving them a narrower total field of view, around 110 degrees, but a far larger portion, about 64%, is binocular. This adaptation allows owls to judge distances with remarkable accuracy, vital for swooping down on prey in the darkness. Speaking of darkness, most owls are nocturnal hunters, relying on their eyes to navigate and hunt when others sleep. Their vision is optimized for nighttime activity, thanks to two vital adaptations. First, an owl's retinas are densely packed with rods, a type of photoreceptor cell. All vertebrate eyes contain rods and cones. Cones function best in bright light and allow animals to see colors, while rods are much more sensitive and excel in low-light conditions. In most owl species, rods outnumber cones by around 30 to 1. This abundance of rods gives owls the ability to see in near-total darkness, far surpassing human night vision. The great horned owl and barn owl are just two examples of species whose retinas are dominated by rods, enabling them to spot the faintest movements of prey under the cover of night. The second adaptation for nocturnal vision is a phenomenon called eye shine. If you've ever seen an owl's eyes glow eerily in the darkness, you've witnessed eye shine in action. This effect is caused by the tapetum lucidum, a reflective layer of tissue situated behind the retina. When light enters the eye, it passes through the retina and hits the tapetum lucidum, which bounces the light back through the retina, giving photoreceptors a second chance to absorb it. This ingenious mechanism dramatically boosts the available light, enhancing the owl's ability to see in dim conditions. The reflected light is what produces that ghostly glow, a hallmark of many nocturnal animals. These adaptations work together to make owls among the most efficient nocturnal hunters in the animal kingdom. Their vision allows them to spot the faint glimmer of a mouse in the grass or the subtle flutter of a moth's wings. An owl's silent flight, combined with its extraordinary eyesight, makes it a formidable predator. But the story doesn't end with their vision. The sensory bristles around their beaks, the ability to rotate their heads nearly full circle, and the enormous size of their eyes are all pieces of a complex evolutionary puzzle designed for survival. Despite their specialization, owls do face some limitations. Their farsightedness means that close-up tasks, like preening feathers or feeding chicks, rely heavily on touch and other senses. The inability to move their eyes might seem like a disadvantage, but evolution has equipped owls with compensatory features that more than make up for it. Their binocular vision gives them depth perception that rivals even the most advanced predators, while their night vision allows them to thrive in environments where others fail. Owls remain a symbol of wisdom, mystery, and stealth. Their eyes, fixed in place yet full of secrets, remind us that nature's solutions are often more ingenious than we can imagine. The next time you see an owl perched silently, its head twisting with uncanny precision, remember the hidden adaptations that make this bird such an extraordinary nocturnal hunter. From tube-shaped eyes and sclerotic rings to rod-packed retinas and glowing tapetum lucidum, the science of owl vision is a testament to the wonders of evolution, and a reminder that sometimes seeing the world differently is the greatest advantage of all.